So today we're going to start looking at erosion by wind. There's a fancy name for that. An aeolian process is activity, erosion, and deposition from the wind. We've got to understand that wind can also pick up and move sediments, just like water. Here we can see it's kind of a desert environment. You see out there in the distance, you see all of that looks like dust being kicked up. Well, those are sediments. That's stuff that is being moved around. We can see it up in the air. Well, there's obviously no water here. Water doesn't pick up stuff and throw it in the air. That's all sediments that is being picked up by the wind. This is an example of an aeolian process. And wind moves stuff, causes erosion a little bit differently than water does. So that's why we're going to examine it and its terms and its explanations by itself. So some factors that affect wind erosion. I conducted a little bit of an experiment here, and I put equal amounts of sand and clay in the pan, and I turned on a hairdryer, and I turned it on for the same amount of time, about 30 seconds, and I turned it on at the same speed rating, low, and I observed the results. And what you notice here is so much more of the clay got moved than the sand. The clay got moved more and it got moved farther than the sand. Well, what do we know about clay and sand? We know that clay is significantly smaller. And just like with water, smaller stuff gets moved easier than bigger stuff. So clay erodes more than sand. So our first factor that affects the amount of wind erosion is the size of the particle being moved. The smaller the particle, the easier it is for wind to erode it or move it. Now the second factor, I set this experiment back up and I had the same amount of sand, had it set up, but the difference between these two is this one over here, I ran the dryer on a higher speed. Over here, I ran it at low speed. So it's like we had more wind over here, or we had a stronger wind. And you see the results. The strength and the duration of the wind greatly determines how much stuff gets moved. The air dryer set on the higher setting moved more stuff, and it moved it further down the track. So a stronger wind and a longer blowing wind is going to cause more erosion. Now, how does wind move material? There's some names for this, and surprisingly enough, it's very similar to the same processes that we saw in the water. So it's going to make it kind of easy. Saltation. Saltation is when we get that bouncing of material. We get kind of medium-sized stuff that gets pushed and bounced along, and it bounces along the ground. Creep, however, is the one where it's a little bit different. This is like traction in the water, but creep with the wind is when the particle is so big it can't get up into the air and it kind of rolls or slides across the ground. Suspension is just like it was in water, where you get stuff that's really, really small and it's like floating in the air as opposed to floating in the water. This is an example of what suspension looks like, what you and I would typically call like a dust storm. And that's stuff, that's sediments that are floating up into the air. When the wind dies down, this stuff will fall out of suspension just like it does in the water and wind it back on the ground. Now, saltation is the bouncing of stuff across the surface, so really low to the ground. This right here is the Great Sand Dunes National Park in Colorado. And you can see how it looks like there's a film of stuff moving right across the ground. That's saltation. That's wind bouncing a bunch of little stuff across the surface. It's not up in the air. It's not suspended. It's just bouncing right across the surface. And you can see that in my experiment. When I turned on the hairdryer, I was pointing it here into the pan, but you'll notice that some of the clay came out. Well, I wasn't pointing my hairdryer over there, but as the clay moved, it bounced down the pan, and some of it bounced right out. The same was true over here of the sand. This is called saltation. And this is just like in water, where it's the bouncing of stuff, and some of the stuff bounced outside of the pan. Creep. You don't see this as much with wind as you do with water, but it's the slow movement, but it's the rolling or sliding of big stuff across the surface. And usually what has to happen is the surface has to get a little wet, like you see over here in this picture. This is called the racetrack playa in Death Valley in California, where we see these really big rocks moved across flat surfaces. And for a long time, scientists didn't get how this worked because it's a really big rock, and the wind can't move that big of a rock, especially across flat ground. But then they kind of figured out that when the desert bed got just wet enough, it became really, really slick because of the clay there. And the wind could blow hard enough to slide or creep those really large rocks across the ground. So the concept of deflation. Let me stress to you that the ground is not exclusively made up of sand or clay or rock. It's generally a mix of all different sizes of sediments, no matter where you are. Even though I say here we have mostly clay in our soil, there's rock, there's sand, there's silt, there's all kinds of sizes of materials. And when the wind blows, we know that the wind picks up and moves the smaller stuff first. Now here in our area, we generally have a lot of plants and trees growing. And we got grass and plants and trees growing that really hold the small sediments in place, that hold the soil in place. But in a dry environment, like in a desert, where you don't have a lot of plants, the wind can actually move the small stuff away a lot easier. And you see that. The sand winds up somewhere else, and all the small stuff gets blown away. And what you see left behind is the big stuff underneath. And you can see that here in this picture. You can see the rocks now because all the small stuff has been blown away and all the big stuff was too big for the wind to move it. This is a process called deflation because the land appears to be deflated. It's actually a little bit lower than it was before because all the small stuff on the surface has been blown away. Here's a good example of what deflation looks like in the desert. Deserts aren't typically big masses of sand like we associate them to be. Yes, there are sand collected in other places, but a large part of the desert tends to be this kind of loose, rocky kind of environment. And this is because the wind has blown away all of the small sand, silt, and or clay that was covering up those rocks. So this is deflation, where wind moves away the small stuff that's on the surface. Now here's a case where the wind was blowing along and it was hitting solid rock, and it actually removed sand from sandstone. It blew away part of the sand that was making up this sandstone formation, and it makes a very unique shape. The wind can actually make shapes out of rock as it moves part of the sediments away. The Sphinx in Egypt was that way. The wind has blown away parts of the rock that makes up the Sphinx, and now it has a very different shape to it than it did a couple thousand years ago when it was built. This is an example of wind erosion. The wind is moving stuff away. The wind can blow sand and blow pieces of rock at and away from different types of rock, and it winds up being some very unique shapes. This was only caused by wind. This would not have been caused by water because you see all these rocks, they are not sitting in water. Same concept here. That hole in that rock was not caused by water going through there. This was not eroded by water. That was eroded by wind going through that opening. And now, as more and more wind gets forced into that opening, it's forced to move a little faster. That opening is going to get bigger and bigger over time because the wind's going to blow stronger through there and then move more stuff out of the way. There's a name for these rocks that have these crazy weird shapes caused by the wind. They're called ventifacts. A ventifact is a rock that has been sculpted by the wind. It's been eroded by the wind. Some of the material has been moved away by the wind, and now the rock has a very unique shape to it. Now, where is wind erosion worse? You can see here on this map that wind erosion is much worse in the middle part of the country. We also have along the coast, albeit to a lesser extent. We're going to look at that middle part of the country and try to explain why. We're going to call that the Midwest.
So let's talk about why there's so much wind erosion in that middle part of our country. So let's talk about why there's so much land back here behind me. You can see that it is entirely flat, which when there's nothing to block the wind, either buildings, mountains, trees, the wind can get going and it can pick up speed, and therefore it's going to pick up more stuff more easily and cause more wind erosion. Second reason is I'm here in Kansas. In Kansas, in the middle part of the country, way away from the ocean, where you get that mixture of hot and cold air. Things get hot and cold very easily. Well, that makes differences in pressure that are higher and lower, and therefore will cause the pressure differences that give you wind. Now, the third reason, and one of the more important reasons, is look behind me. This land in this part of the country is used for farming, and for a good portion of the year, there is no plants in the fields. Well, without any crops, any plants in the field to hold onto the soil, and you have a lot of wind, you're going to have a lot of wind erosion. So, to summarize, the reason why there is so much wind erosion in the middle part of our country, in the Midwest, is because there are a lot of farms and there's a lot of wind.
So farmlands have a really big problem with wind erosion, not nearly as much with water erosion, because farmlands are just open soil with no plants on them for a good portion of the year. Most of this farmland in the Midwest, where it's very windy, farmers have a problem with wind erosion, and it's a big problem for them because a farmer does not want his soil to go away. A farmer needs his soil in his field because his plants, his crops, depend on a good soil in order to yield whatever crop they're growing. So, farmers got to do something. They got to do something because they have very little to block the wind, and it's just open soil for a large part of the year. So let's talk about what can a farmer do to help prevent wind erosion. Well, before we move on to that and talk about the Midwest, let's look at Georgia. We don't have the problems with this wind erosion in Georgia for two reasons. One, we have so many plants on the ground here. So our plants really help to hold the soil in place. Two, we just don't have as much wind because we've got the hills and the trees that block the wind and keep it from getting so strong. So what can you do to prevent or lessen wind erosion? Here's what farmers do. Farmers will plant rows of plants or especially trees between fields to help lessen erosion. Because what happens is it kind of blocks the wind. So as the wind gets going here in this field, it can't get going too fast before it hits a row of trees. And when it hits the row of trees, kind of no matter which way the wind is blowing, it's got to stop and slow down a little bit. And the slower the wind, the less likely it is to pick up and move sediments or move the dirt, the soil in your field. These are called windbreaks. A windbreak is simply a row of trees that are planted to stop the wind from picking up sediments. And they're very, very common in the Midwest where you have a lot of farms and you have a lot of wind. Here's one where a farmer decided, you know what, I'm having a problem here. I need some more new trees to help make the wind slow down. And he went along and he planted these trees beside his field, between his field and the road, to keep the wind from blowing his soil out of his field. Now, wind can move stuff. It can also deposit stuff. Think about this situation. When the wind moves, it's going to take the sediments and it's going to drop them somewhere. Now, this is a little bit different experiment that I did where I put a little pile of rocks in the way of the sand, in the way of the wind. So I was blowing the hairdryer this way, trying to move the sand down to the end of the pan, but I put some rocks in the way. And just like rocks make water slow down, they also make wind slow down. So the wind will drop its sediments right there. And it gets to a point where I can't even see the rocks anymore. They're just covered up by sand. If I kept blowing sand there, that pile of sand is going to get bigger and bigger. I don't even know there's rocks underneath there. And it doesn't have to be where wind is hitting the pile of rocks. It can be anywhere where wind slows down and it starts to drop its sediments. Could be once it kind of goes into a low point, or it gets far enough away, say, from the coast where the wind starts to die down. It can be up against the wall of a canyon. It can be a mountain. It can be a lot of things that change the speed and or direction of the wind and make it drop sediments in that spot. That leads to the formation of a sand dune. A sand dune is just simply a big pile of sand that was dropped by the wind. You'll see these at the beach. Obviously, this is a desert sand dune. We also see these at the beach. What do we know about the beach? There's a lot of sand around, and there's a lot of wind. Most of the dunes that are at the beach weren't caused by water. They were caused by wind blowing the loose sand around, and they piled up near the shore. So a sand dune is just a pile of sand that was deposited by the wind. And they have a very particular shape to them. You don't see it as much with beach dunes, but you do see it in desert dunes. One side of the dune will be a pretty shallow grade, and the dune gets higher on that side, and then all of a sudden on the other side, it seems to drop off pretty steeply. That is called the slip face. The slip face of a dune is the one facing away from the wind, and it tends to be steeper than the side that's facing into the wind. That's what happens. The wind's piling up sediments, and the dune gets bigger and bigger to a point. If you've ever tried to build a mountain of sand, you know at some point gravity takes over and pulls it down the other side. Now, it can still get taller because the wind is still pushing sand up, but the side of the dune that's not getting hit by the wind loses to gravity, and you wind up with a very steep side of the dune, and that's called a slip face. Great Sand Dunes National Park in Colorado is one of our national parks. It's very unique. It's a huge collection of sand that was deposited by the wind over thousands of years. And you can see by the size of the people in this picture, they are hundreds of feet tall. The winds come across the Rockies and they pick up little pieces of rock, sand-sized sediments, and they get to this point here and it starts to drop them. And the winds have kind of always blown in the same direction. So over thousands of years, this sand has been piling up and made some very, very large sand dunes. Now, Loess. Loess is a fancy name. Loess is not just a sand dune. Loess is the mixture of any small material, it could be sand, silt, or clay, that is deposited by the wind. So we think of sand dunes very obviously being made by wind, but if wind can blow sand around, it can certainly blow silt and clay. And it has. In the middle part of our country, we have huge, what's called Loess deposits. The ground there is primarily made up of this really fine material that the wind blew there and dropped off. This is the sand hills of Nebraska. And we don't think of Nebraska when we think of sand. We kind of think of sand being near the beach, but the whole central part of Nebraska is a bunch of sand. It's a bunch of Loess. And this was material that was blown there over thousands of years, and it piles up. It looks like a bunch of sandy dunes, hence the sand hills. They're covered with grass, but if you go and stick a shovel in there, you're going to hit sand. This is a very important area for that Ogallala aquifer that we talked about earlier, because when it does rain here, because this is Loess and it is pretty sandy, the water will infiltrate the ground really easily and then recharge that aquifer. It's especially important when the ground gets covered in snow, because snow melts so slowly that it goes into the ground a lot more easily than, say, rain from a thunderstorm. So this is the sandhills, and it's a collection of loess, or wind-blown materials that have piled up, and this happens primarily in the middle part of our country. Now that's the end of the presentation, but I do have a summation for you that I want you to take notice of. Can you answer these questions from your notes? This is what I'm going to quiz you on. This is what I explained to you. If you don't have a good explanation or a good answer to these questions, go back through, skim through, and they are in order in the way they were presented in the video. Go back through and find the answers and the explanations of these before you take the notes check.